Hello everybody and welcome to another Math 1 video lesson. So in our last video, we went ahead and covered investigating the multiplier, which is b. And in today's video lesson, we're going to go ahead and work on identifying exponential growth versus exponential decay. Okay, so let's go ahead and jump straight into the lesson. So I start you guys off by asking this simple question: what is the difference between exponential growth versus exponential decay? And if you guys remember from our last video, I told you that when b is bigger than 1 or greater than 1, so numbers like 2, 3, 4, so on and so forth, then we call that the growth factor or exponential growth, okay? But when b is between 0 and 1, so for example, 1/2, 1/3, 1/4, then we call that this decay factor, or the function of that, we call it exponential decay function, okay? So as a reminder from last time, also, the a in an exponential parent function represents the y-intercept. And again, the b represents the multiplier, okay? So whatever that a value is going to be, that's going to be our y-intercept, okay? So let's answer this question. What's the difference between exponential growth and exponential decay? Well, exponential growth, as you guys remember, increases, so the y values increases as the value of x increase. So you see, when x is 1, our value is going up, our y value. When x is 2, it's going up even more. So this is increasing when you're looking at it from left to right, okay? Again, the parent function is the same for both because they're both exponential functions. But the difference is that here, b is going to be greater than 1, okay? So what's some examples of this greater than 1? Well, example, 2, 3, 4. What about 1.2? What about 6.39? So all these numbers work. If it's greater than 1, then we call it exponential growth. What's exponential decay then? Okay, so exponential decay, the y values, so when we say decreases, what decreases? The y values decreases as the value of x increases. So you hear, if you look at this from left to right, the graph is going down. So at 1, if the number, let's say, was 2, then at 2, it's going down. At 3, it's going down even more. It's getting closer and closer to the x-axis, okay? The parent function is the same for both. The only difference is that here, b is between 0 and 1. So what's an example of this? What are some numbers that would work out? Well, 1/2 would work. 1/3, 0.5, which is the same thing as half, okay? 0.732, and so on and so forth. So again, any number between 0 and 1. Notice it is not equal to 1. It is not equal to 1, okay? It has to be greater than 1 or less than 1. All right, let's go ahead and jump into the examples for today. So these examples are the same examples that are in your packet. I know that I said that I was going to go over some practice problems, but to be honest with you, these are very similar to the practice problems, almost word for word, okay? Now, I do know that the first question in this specific day of the practice problems doesn't really relate to the day's concept as much. It more so relates to yesterday. So I want you guys to just pretty much evaluate and graph the exponential function, okay? So let's go ahead and jump into this specific example. It says, identify whether the function is exponential growth or exponential decay. So what would we need to look at over here? So it would help you to remember what the parent function of an exponential looks like. So y equals a times b to the x power. So I know my b is going to be the value that has the x that's raised as an exponent to it. Let's look at our b. What's our b equal to in this situation? Well, b is equal to 3 in this situation. Well, I know that 3 is greater than 1. So in this specific situation, b is greater than 1. And because b is greater than 1, is that growth or is that decay? Well, of course, that's going to be growth because that's what we agreed upon. So this is going to be an example of exponential growth. Okay, exponential growth. Let's go ahead and take a look at the second example. So again, you have this function, f of x equals 0.75 to the x power. F of x and y are the same thing. They're kind of the same thing, just so you guys know. So I know my parent function is y equals a times b to the x power. Okay, well, b, my b value is that value that's raised to the, that has an x raised to it, I should say. What is b in this case? Well, b in this case is equal to 0.75. Well, I know that 0.75 is between 0, that is a messed up 0, and 1, okay? So if b is between 0, greater than 0, but less than 1, then we call this exponential decay. So it's going down, okay? It's dying out, okay? So let's go ahead and take a look at the next example. So very simple. How do you determine whether or not a function has exponential growth or exponential decay? Simply look at the b value, okay? So I'm going to teach you guys right now how to do it in regards to a table. But real quick, I want to point out something. What is the a value in this situation? So I want you to think about that for 1 second before I tell you. So what is the a value in this f of x equals 3 to the x power? Well, there's no a right here, right? What does that mean? Well, that's a 1. So a in this case would be 1, all right? What's a in this situation? Same thing, there's no a in the front right there. That means that's a 1 times whatever function you have, okay? So just as a quick note before we move on. In our second example, it says, identify whether the table represents exponential growth or exponential decay, okay? So if you guys remember from last time, so I'm telling you it's either growth or decay. So if you guys remember when we were working kind of on arithmetic sequences and when we were working on linear functions, if we wanted to figure out the slope, we could find the common difference. So you would subtract the two values that you have to find the common difference, or in regards to the slope, you would do the y2 minus y1 over x2 minus x1, and you would figure out the slope. Well, with exponential functions, it's a little bit different. We're not adding or subtracting anymore. This time we're going to be either multiplying or dividing. So let's go ahead and take a look at this table. What happens each time to go from 2 to 4? And 4 to 8, and 8 to 16. Well, it's kind of obvious. Each time we're going to be multiplying by 2. So times 2, times 2, times 2. But what if it wasn't as obvious, right? So what if you didn't know? Well, what is a sure-proof way to figure out what my multiplier is going to be? Well, it's very easy. All you would have to do is grab a second value, so a second one, 32, and then divide that number by 1 before it, the one that comes right before it, so 16. So if I wanted to figure out my b, I could just say, well, 32 divided by 16, that's just going to be equal to 2. So my multiplier is 2, okay? So let's do it in this case. And in this table, I want to do the opposite. So instead of trying to figure out with arrows, what do we multiply or divide by? Usually I want it to be multiplied by some fraction. What I'm going to do is I'm going to do the rule way. So I'm going to grab a random number, okay? So let's grab this number, 27. And I'm going to divide it by the number that comes before it. So divided by 81. Okay? So 27 divided by 81, what is that going to give us? What is it going to give me? 1 over 3. Okay? So I know 27, if I simplify that, divide by 9, divide by 9, you would end up getting, or divide by 27, divide by 27, you would end up getting 1 over 3. So you could simplify it whichever way you like, okay? If you plug it into the calculator, 1 divided by 3 is going to end up giving you 0.333333, okay? So you got 0.3333. So that's what I know my multiplier should be. So let me check right here through the arrows. So if I multiplied 81 by 1 over 3, is that going to work? Well, let's see. You have 81 times, actually let me do this, 81, and use parentheses, 1 divided by 3. That's gonna give me 27, so it works out. But what if I multiply that by another 1/3? So what if I multiply 27, right, by another 1 over 3? That's gonna give me 9. Well, obviously that ends up working out. So this is definitely each time we're multiplying by a third, okay? So in this case, because my b is between 0 and 1, it's a fraction, okay, that's between 0 and 1, we're gonna call this exponential decay. Versus this one, because my b value was greater than 1, we're gonna call this exponential growth. And that pretty much does it for this specific video. So again, the things that you want to walk away from today is the difference between exponential growth versus exponential decay. Exponential growth, the y value increases as the x value increases. In decay, the y value decreases as the x value increases. B is greater than 1 for the growth. B is between 0 and 1 for the decay. So take advantage of this video, pause it, take notes on it if need be, and have a good day.